on 3/8 is just a second example. We actually could go through and derive for the tangent. We could derive for the secant. I've got that work if anybody wants to try that. You could try a couple of the other examples that are going to be in the notes, and I could show you what it looks like worked out. It's also worked out. Actually, not all of them are worked out in the book, but you could find a couple worked out in the book where you actually derive, like, what is the derivative of the inverse of cosine or the inverse of tangent. And then really I'm going to end up giving you these, and kind of like, what's the derivative of sine? We just have that memorized cosine, right? We don't have to go back and redo that every single time. That's the same thing we're going to be doing here. What's the derivative of cosine inverse? And you'll know what the derivative is, and we'll use that. And some of the other properties and identities that come up in this section, I know that we're going to be able to skip over. So, yes. Yep. I usually like to let you think about it and forget about it. We'll probably write them up on the board tomorrow and let you forget about it, and then we'll make note cards so that you write it down like 3 or 4 times so that it sticks. So then you don't have to really put a lot of effort in memorizing because you've just written it down a few times and then you know it, or you've used it in the homework. So here's the idea. The inverse is going to be rewritten in terms of y instead of in terms of x. So if I could, there we go, get that started. I'm just going to switch the x and the y, representing the same function, just, definitely looks quite a bit different. And we're going to go ahead and find the derivative of this, which we needed to have done that last section first because we're going to have to do derivatives with y's and x's. First part will be easy though. What's the derivative of x? That's just 1. What's the derivative of cosine of y? That's negative sine of y. Okay, except an extra dy dx. But that's not too much time before I'm able to just divide and say, okay, 1 over negative sine of y and have my derivative. But I don't want my derivative in terms of y. Not that that maybe wouldn't help us at some point, but more likely we want it in terms of x since we have the derivative or the change in y over the change of x in terms of x. So if you look up above, this is really, really similar to what we're doing. We're actually going to end up using the same identity. So if you look at what we did yesterday, I've got the same thing. I have x equals sine of y. So instead of cosine, we had done sine. And I've almost got the same derivative, but instead of 1 over cosine of y, it's 1 over negative sine of y. Well, if we could steal this same thing here, so whether we did sine squared plus cosine squared equals 1 and solved for, like we did here, and solved for sine, or whether we solve for cosine, we're still going to get kind of the same thing. So if I solve for cosine in that identity, it would have been cosine of y equals 1 minus sine squared of y. And if I plug that back in here into my original equation and kind of solve, I'm going to get the same thing. The only difference is the sign we end up with. So let me kind of jump past part of that, but not so much where you won't follow. So what I'm saying is if we took this identity, again, same one, sine squared plus cosine squared equals 1. And this time, instead I solved, last time we solved in terms of, you go back up here, last time we solved and got it in terms of sine. This time I'm going to solve it in terms of cosine so I can set it equal to x. But I get the same thing. I'd get cosine of x equals, or actually let's do it. Let's just leave that off and we'll look at what we want. I'd get cosine equals, subtract, plus or minus 1 minus sine squared. So same type of identity. And what I really want to do is I want to replace this sine of y down here. So I want to be able to plug that sine of y in with something that's in terms of x. So what does sine of y equal? Okay, I'm going to combine this equation like we did yesterday. So I have x equals cosine of y. Well, what I'm going to do now is I'm going to say, okay, what does cosine of y equal? Well, so instead of cosine of y, I'm going to say plus or minus 1 minus sine squared of y. And what I'm going to do is I'm just going to solve this for sine of y so I can, again, go back in. And the whole idea is I want x's down here instead of y's. And that's what I'm trying to do. just get the sine of y in terms of x's, which with this equation I've got, I should be able to do that. Square both sides. Minus the 1. Maybe some of you are already farther along than that. And take the square root. Now, I did this a little bit differently yesterday, and it worked out okay. It looks like if I take the square root, what would end up happening? So there's another way to do this. Last time I did this, let me pull this out to make sure I say this right. Last time I did this, I actually worked the other way and found what y equaled in terms of x and plugged that back in. I'm thinking maybe that would have been a better way to go. Yesterday it worked out okay. Let me find it here. Nope, not there yet. Where are you at? Not too far. Yeah, shoot. Yesterday, or the time I did this before, what I actually did was I solved for y instead of for x from the beginning. But what all that ends up happening, and I don't want to take time, so maybe I'll have to come back and show you because I don't want to go through and find exactly where that was. What we looked at yesterday was really close, and we ended up looking at the domain. I wonder if that has something to do with it here, but I don't recall, so I don't want to just say that I know what it is if I don't remember. But this is really close to getting the same thing where all we're going to end up doing anyways is remembering that we have the same thing as yesterday. Oh, you know what? I know why. Because all I would have to do is change the signs, right? Is that what you said? Oh, yeah, smart. Sweet. So all I'd have to do is change the signs, then take the square root and get the square root of negative x plus 1. We usually don't write it like that. Equals sine of y. Yeah, and then I'd be able to plug it in. So this is where it worked again. I just know that I've done it another way, and I thought, well, shoot, maybe I had to do it that other way. But no, that worked okay. Well, because I couldn't have taken the square root of both sides with the negative on that side, because then I would have been able to have sine. I would have the square root of a negative. But I don't care what I get over here. That's just going to be a mess. It's going to be part of our formula. I'll deal with that. But I needed to have it in terms of exactly sine of y to be able to go back in and plug it in on that left equation. So now I can go back finally and say, okay, well, what's dy dx? It's 1 over, and actually that's the same exact thing we got yesterday. The square root of 1 minus x squared. The only difference now, is because of our derivative being the negative sine of y when we take the derivative of cosine, you get negative. And if I wasn't recording this, I'd probably write these up on the board, but I'll kind of write them right here below. So here's what we're remembering, and this is really what you need to take away from this. And we'll, like Alex was asking, we will go ahead and write these on the board tomorrow. We'll make note cards of them. The derivative of cosine inverse of x and the derivative of sine inverse of x are the exact same thing. They're 1 over, so if you remember the one, you'll remember the other, 1 minus x squared. Except one of them is going to be negative. So if you look, the one we just did was negative. The one we did yesterday was positive, and that's been pretty typical. So when we did the sine inverse, we got positive. When we did the cosine inverse, we got negative. And this is going to be pretty easy to remember. Let's see, cosine inverse was negative, sine was positive. For these others as well, because if you can remember the derivative of tangent inverse of x, it's going to be the same type of thing. You'll know cotangent. And if you can remember the secant one, it'll be the same thing with the opposite for that one too. So this one, a little bit different, but close if we derive it. And like I said, if you want to see it, I can show you that. I have it in the notes that I had gone through and done. But it's the only one that's plus on the bottom, and the only one without a square root. So that's tangent, just one of the ways we'll remember that. So if you want to know what the derivative of the cotangent is, It's the same exact thing, so you don't have to remember another one, except instead of positive, it's going to be negative. And then there's two more. We need the inverse for secant. And we need the inverse for cosecant. And this is the harder one to remember. But maybe you remember that it's kind of the most unusual, and it kind of looks the most unusual. It's going to be really similar again. So we're going to have the square root, except this one's going to have the absolute value of x on it. So if you're looking at like what's the difference between this one and the other ones, again, because of the way we're deriving, it just kind of works out a little funky like that. This is also going to be subtraction. Let me just double check. See if I can remember a whole year later. Which is it the same? Yeah, that's sweet. That's what I was thinking. It's 1 minus x squared, 1 minus x squared. So just exactly the same as the cosine and sine, except, again, you got the extra radical. And I think I'm pretty sure it's the same way. Yeah, so the derivative of cosecant is the negative one. Secant is the positive one. And so what we're going to do is we're going to do some of these, and we're just going to remember them and go ahead and plug it in. Yeah. Let's see. Gotta factor that out. Different day. Yeah, that's right. I almost told you. I'm glad you brought that up because I looked back and double checked, and it is. So if you take a moment, sorry about that. Like I said, we're just memorizing those. I haven't used them in a year, and before that, it's been like 10 years. So I just got to recall myself and just stick with them or get them to stick. Which, you know what? You guys will ask enough questions. You guys will probably see more than I do because you'll end up doing a couple more problems probably than I'll end up doing as you're practicing. But it'll stick in my mind. I'm sure you do what you need to get done. It'll stick in yours as we go along. But look at some of the things that are similar to help remember them. Look at some of the things that are different. And we'll, when you come tomorrow, like I said, we'll just recall them. We'll write them on the board and try to remember some of the things that were unique about each one. And I think what I'm going to end up doing is doing a couple of homework problems with you already. So if you go to, instead of doing some more notes, if you go to your homework, we're just going to start using these. And you'll see. So take out your book. A little bit different than we've done any other time. Go to page 170. It's a little bit of how we're going to streamline this section, where really all you need to take away from this, there's some other things that we're not going to use very often, so the main thing you need to take away from this is these 6 derivatives. All right, so 3/8, starting with number 1. And I'll just keep recording this. So if you guys want to go back and look at a couple of these, and maybe if you see one that's a little harder, we got enough time today, we could do maybe one of these towards the beginning that are easier, and maybe try one that's maybe looks a little bit harder. But for number 1, we'll end up with y equals cosine inverse of x squared, which, here's the idea. As long as we have this memorized, anybody without looking, now that it's gone, could tell me a little bit. What are you guessing? So recall it. What's coming to your mind? Without even looking, you remember which one's negative? Okay, so it's either -1 or positive. It's the square root probably. Remember, it's x squared minus 1 or 1 minus x squared. Sure? It's one of those two. It's a minus. The only one that's plus is the tangent and cotangent. It's a 1. And maybe it'll help that I just kind of wrote that down wrong a minute ago because I'd written the same thing down for the secant and cosecant, but it was supposed to be x squared minus 1. All right, did we get the sign right? Okay, so that's the whole deal, except is this just an x? No, so right here, the only thing that's going to change is instead of saying x squared, that's not just an x. We need to change that. So we're going to erase that and just plug in the x squared. That's it. That's all that's going to change. So instead of x squared, we have x squared squared. Okay, that's not true either. What else is going to change? From what you already know, what else should change? Is your inside just x? No. So what do you do when you have an inside other than x? Multiply by its derivative. So what's the derivative of x squared? 2x. And that's it. If you have it memorized, you just make sure you replace x with what it needs to be replaced with. You multiply by the derivative of the inside. There's a couple algebra questions that may come up that are a little bit tougher to work through. But that's really the only difference of what we've already been doing. How does that simplify? Cool. Yeah, square root of 1 minus x to the fourth. Not as hard as you thought, maybe? Just a couple more things to memorize. But that's okay. We'll get some practice. Morgan, how far did you get? You have one you get stuck on? You want me to go through, or you have a preference if you're looking at that? I know you were kind of ahead a little bit. Okay. So we want to do maybe number 7. So jump down. I'll do number 7 with you. And tomorrow you're going to get a good chunk of time to work on this in class as well, and just kind of try some of these, and I'll do some with you again maybe to start. So number 7, we've got x times sine inverse of x plus the square root of 1 minus x squared. This actually is not going to practice what we just learned very much, but that's okay. It'll still get us in the mix of some of the other things we've learned. So what have you learned? What do you know about what we're doing here? How about let's take it a term at a time. So let's start with the x times sine inverse of x. That's a product. Yeah, okay. So it's a product. We have to do vu prime plus uv prime. So just a matter of taking a little bit of time. It's going to be drawn out a little bit, but we can do that. So you've got the sine inverse of x times the derivative of u, which would just be 1. U, which is x, times the derivative of sine inverse. Again, that's something we're trying to memorize. So we know the square root's on the bottom. We know there's a 1. We know it's a minus. The only ones that are plus are the tangent and cotangent. And the one we just did before you can see, so you probably know we're going to do 1 minus x squared. Now this one, actually, there is no, it's just sine of x. So that x squared, we don't have to worry about that being something other than just x there. It's just going to be that x and then squared. Positive? Yeah, because the one we just did was negative, so sine must be positive. Is that really all we're doing? Sine inverse of x plus, I guess that would be x over the square root of 1 minus x squared. We got another term, though. So let's rewrite this. I think it's a lot easier for students to follow if we rewrite this to the 1/2. So, again, looks pretty similar to, I'm just rewriting this. Looks pretty similar to what we were doing with our chain rule, or the power rule. 1/2 times 1 would be 1/2. You get 1 minus x squared to the negative 1/2. And I'll rewrite that then with the terms I have going here back where we were at. So that's plus a 2 on the bottom and the square root of 1 minus x squared. So that's that third term. You think they left it like that? I'm guessing they probably didn't. Did they leave it like that? Do you see how close the, yeah, I have a couple, yeah, I would probably just leave it like that. Sure, just go for it. Do you see how this one has pretty close to the same denominator? So I wouldn't be surprised if they noticed that and said, well, let's add those together. But again, that just depends on how far you want to go with it. And yes. Okay, but the inside was just an x. Oh, crud. Yeah, so we would. Okay, thank you. Way back up here, times the derivative of the inside. That's like strike 3. We're done. Having an off day, I guess. So that's an extra negative 2x. Oh, man, then I definitely want to do this because I don't know if you can see this far ahead. But if I end up with that extra negative 2x here, and I get a common denominator and multiply the bottom of this times 2, what's the top going to be multiplied by? 2. And when you combine those, what's 2x minus 2x going to be? 0. That's going to work out so slick. So yeah, definitely I'm going to end up doing that now. So if you didn't follow that, what I'm saying is I'll do this in different color. We'd end up having the extra 2 there, to get a common denominator, and you're going to end up with the sine inverse of x. And then I think we're going to end up with 2x minus 2x. We're going to end up with 0 over that mess, which 0 divided by anything is, well, that cleaned up quite a bit. Tanner? Yeah, okay, so maybe that would have been even easier. Saying like, so you could have just canceled out the 2, got the same thing instead of doing that. Is that what some of you guys did? And then you would just had x minus x, still get 0. Okay. You want to do one more or you want to try one? I'll do another one with you if you want to just do another one from the homework, or you'd rather... Okay, I got enough yeses. If you want to do it on your own, do one on your own then, but I'll do another one for those who are saying yes. You have a number 5? Okay. Number 5. Y equals sine inverse of 3 over t squared. Whoops, can't even get it copied down right today. 3 over t squared. Which, again, is something that we are memorizing, right? So, we just did that. We've got 1 over 1 minus, but okay, instead of x squared, here's where the difference is. It's not just sine inverse of x. So instead of having x squared, I have to change that to 3 over t squared. And it's not just x, so there's not just, inside isn't just x, so you have to multiply by the derivative of the inside. So what's the derivative of the inside? Thanks, t squared. Well, maybe I'll rewrite this as 3t to the negative second so I can use the power rule. And then your derivative of the inside would be negative 6t to the negative third. Cool? So the derivative of the inside, if I was going to rewrite that, might look something like that. And now, again, that's actually not too bad. We're just basically plugging into the formula that we're memorizing that's equal to the derivative, and now simplifying. Yes? That's okay. Well, we're not done yet. So if we wanted to simplify this, I haven't even started to square this out. Oh, I see what you're saying. Well, it just depends on what we prefer to work with. If I want to see, sometimes you might have something that would simplify more nicely, or depending if we could combine a couple terms. If I could find a denominator. I know sometimes it'll work out slick. If I take the 1 minus, well, what I get after I square it is 9 over t to the 4th. And if I, actually combine it into 1 and say, okay, so let's put it over t to the 4th. So I end up with a t to the 4th over t to the 4th to make that a common denominator. I'll end up with t to the 4th minus 9 over t to the 4th. And let me show you what will happen when I rewrite this now. If I left that on the top, we can do something with that or move that t cubed to the bottom when we're ready. But watch what happens if I take the square root of this now. If I go ahead after I've simplified that and put that back in, what's going to happen with that square root? Where's my algebra gurus? What's going to happen with algebra gurus? What's going to happen? The t to the 4th, what's the square root of t to the 4th? T squared. So you're actually going to get just the square root of t to the 4th minus 9, but you're going to have that over t to the 4th, which, maybe I'll move this to the bottom now. I'll leave that negative 6 up there, and I'll move that t cubed back down to the bottom. What's going to happen there? No, because when I took the derivative, I had 1 less power.
No, I'm saying it's over t squared.
Oh, yeah, so now it's over t squared. I got you. Thank you. And so that's actually going to start simplifying quite a bit. It just cleans up quite a bit when you do that. So lots of algebra there. Try some of those ones that are left over from the first section for tomorrow.